this is going to be lesson from section 7.2, the disc washer method for finding volumes of a solid. Okay, so anytime you are looking for volume, volume is equal to the integral of the area of which you're trying to find. So the area will be in terms of a function. So this is representing area. You will integrate it from A to B. So the disc washer method that we are going to talk about in section 7.2, a disc is a circle, and a washer is a circle, a larger circle with a smaller circle on the inside. So by a disc, we mean a circle. Think of a frisbee, think of a solid circle. The area of a circle is pi r squared. If it is a washer, like a bolt and washer, you have a circle and then another circle on the inside. So the area that you're referring to is the donut part. So that area is what I like to call pi big R squared minus pi little r squared. So if you're looking at this, here's your center of your circle, just like the center is here. That's your radius. Here the center is here, the big radius, so this will be big R. Like this one only has one radius. Here's your big R here, and then you have your little r. You're going to subtract out the middle. So if you have the area of the full circle, then you're going to subtract out the area of the little circle. Now, the center of the circle represents the axis of rotation. This is a side view, what you would call a cross section. So both of these views right here are called cross sections. So if your cross section is a circle, you're going to use the disc method. If your cross section is a donut or a washer, you are going to use the washer method. So you want to make sure to identify what your shape is first. Okay, so let's look at a couple of examples. Okay, so the problem, y equals square root of sine x is one function, y equals 0 is another function, x equals 0, and x equals pi. Those are your four functions. You want to find the volume of the solid form by revolving the region bounded by these four graphs. Okay, so we have which looks like this. Here is sine x between 0 and pi. Here is your second y equation right here. So we're going to go from x equals 0 to x equals pi. We're also going to revolve it around the x-axis. Let's just add here about the x-axis. You want to get in the habit of drawing like a little circle to show what you're revolving the graph around, because as we start revolving it around different y equals equations, lines, it's going to make a big difference in your picture. So when you were finding the area between two curves, we talked about bound region. So here is the bound region of those graphs. If we're revolving it around the x-axis, this is your center of your circle. So when I revolve it around, the graph is going to come around like this, and we're going to make circles. Here, let me do this in a different color. We are going to stack a bunch of discs on top of one another. Here's the center of your circle. So if I take one, the radius of these circles is whatever the function value is. So if I want to find the volume, which is the integral of the area of the circle is pi r squared. I'm going to go from 0 to pi. Well, what's the radius? In this case, the radius is whatever the function is. So my equation is going to be the integral from 0 to pi. 0 to pi. I can pull the pi out front, the coefficient that is, and then I write sine x square root, because that was my function, square it dx. From that point, you can type it in your calculator to get the answer. You will always have a pi out front. In this case, this turns out to be 2 pi. So draw a picture every time. Draw in your circle. If it is bound by the axis of rotation, then it will be a disk. A cross section. Our next example is going to be of a washer, so we'll talk about the region not being bound in that case. So our second example, y equals square root of x and y equals x squared are your two functions. Find the volume of solid of revolution when revolved around the x-axis. So find volume when revolved around the x-axis. So let's draw a picture. I want to see a picture with every one that you do. So here's square root of x. Here's x squared. You can see your bound area. We're going to revolve it around the x-axis. So when I do that, it is going to look like this. When I draw in the circle, like this. So I have one big circle, but then I need to subtract out that open space. If I'm looking from the side, the cross section is a washer. Cross section is a washer. This area, the bounded area, this region here, the blue region, is not bounded by the axis of rotation. Axis. When drawing a picture, it's also a lot easier to find your big radius and your little radius. So here we are talking about two circles. So the big radius, my center of my circle is the x-axis. So when I'm finding radius, I have to go to the center of my circle. So here is your big radius. So what function is that? That is square root of x. I'm still talking about circle, so the area of circle is pi r squared. So I want to do big radius, so that's square root of x squared. But then I'm going to have to subtract out the smaller radius. So if I look at that picture, or that radius, there's my small circle, there's my little radius, and that length of that radius is going to be x squared. So I'm going to say minus x squared, sorry, forgot my pi r squared. Now, I have to have a starting point and a stopping point. So where do these two intersect? Where does x squared equal to square root of x? Well, I can square both sides and I get x to the fourth equals x. I'll subtract my x and set it equal to 0. Factor out an x. They intersect at 0 and 1. So that means I'm going to integrate between 0 and 1. Everything is in terms of x. My function is an x. So I have a dx here, and then my interval from 0 to 1 are my x values. And that is all because I'm revolving around the x-axis. If I revolve around the y-axis, everything has to be in terms of y. So you type this in your calculators, and you get an answer of 3/10 pi. Okay, I'd like for you to try some of these. On page 463, I'd like for you to try numbers 15 through 18. I would like to see a picture drawn, the bounded region, the axis of rotation, and then your set up integral. Good luck.